The last video, we were talking about looking at graphs of functions and determining the maximums and minimums, actually the relative maximums and minimums. And we looked at lots of examples. But here's something, I have a couple more I want to quickly show you before we go on to the next topic. And the point of showing you these are to show you that things with graphs are not always neat and clean and precise. All the examples we've done so far, by looking at the graph, it's very clear to know what the values of X were at the maximum or minimum, and to also know the actual value of the function. But sometimes you get graphs like this, and this is just a normal, here's the equation of this graph. Pretty standard looking kind of equation to graph. So it's interesting, if you were given this graph and this function, so here's what's interesting. If you were asked to give the intercepts, be pretty straightforward, right? Here's an x-intercept when x is -2, when x is 0, when x is 1, and then a y-intercept. So you can see those are easy to see because they cross on the exact points. However, what if you were given this graph and you were asked to give the maximums and minimums to give the value of X and also the value of the function? So once again, the function is the vertical axis, horizontal axis, the values of X. So you see that right in here, we have a maximum, and down here, we have a minimum. But if we were asked to find the value of X, because this maximum is not on one of my grid lines, it would strictly be a guess from looking at the graph. I mean, so 1 is right here, here's 2. So this is 1.5. Maybe we could say this is 1.25, but even that, we wouldn't really know for sure. That's just a guess. And then if you look at the value of the function here, this is 2. Now someone might say it's 2, but these graphs are pretty precise. And it looks like to me this line goes a little bit over the 2 grid line. And this one's even more difficult. What if there's a minimum here? What's the value of X? It looks like to me it might be right in here someplace, which we have no idea what that value of X is really. And what's the value of the function? Well, somewhere between 0 and -1. So although we have a maximum in here, if I'm just looking at the graph and asked to give information, I could give an estimate of the maximum end, but I could not really give the precise values. Now I could mathematically, hopefully, go and calculate the precise values, but from this graph, it's not always clear. So just to show you that all the examples we did on the last video, everything was very, let me grab some of those graphs. Everything was very clear and precise, and there was no doubt about the maxes and the mins. And of course, I made them that way so we can learn, right? So we did this one. You know, it's very obvious. This is a 0, 2. And let me find a couple others. This one, although it's a little bit bigger, but if you look closely, well, that one's not the best example. How about, here's a good example. 2 mins and a max, but we can know pretty much exactly this minimum is -1, -1. This minimum is 1, -1. the maximum is 0, 0. So these examples I did were the kinds where the max and the mins were pretty easy to define. Even this one, it's pretty clear what the max and the mins are. So it's not always that way. So just wanted to, I felt like the last video, every example I gave you was very clear cut where the point was, but in reality, a lot of times you have things like this where it's just from simply looking at the graph, you can't really necessarily make out what's going on in terms of the precise values. All right, a couple more topics and then we'll be ready to start calculus. Something else that they're going to ask you about whenever you're given the graph of a function. Here's the question they're going to ask you basically. Where is the function increasing? Where is the function? Now, I think you're going to find this pretty straightforward because once again, we say, where is f of x increasing? We're really saying, what are the values of x? Are the of x where f of x is increasing? So if I made it even more explicit, this answer here is going to be x equals, and the answer is going to be an interval because it's going to be a whole range of values of x. So let's just do a couple quick examples and graph of a function. Let's try and mark on this graph where is the function increasing. So the whole key to this, just like we were looking at with maxes and mins, is you always start on the left side of your graph, the negative x side of your graph, and you move to the right. And as you move to the right, you are tracing out your function. As you move to the right, if you're going up, then obviously the function is increasing, right? The value of each of these points is getting larger and larger. So we have an increasing function. And then at some point up here, maybe I'll just make an estimate, maybe right about here, we have a maximum. In other words, this is the highest, the largest the function gets, because as we keep moving to the right, then all of a sudden the graph begins to decrease, which means the function begins to decrease. So that means for this graph, we would call this the increasing region of the graph. Increasing, the function is increasing here. And then we would say the function is decreasing here. So the reason why the answer is an interval is because we have to include these regions. Let me do one quick example, then I'll come back and explain another important concept. So I'm hoping actually, let me grab my old graph because I didn't print out the one I wanted, but I can use the old one. This is pretty simple. I want something like this, which looks similar to what I was just doing. So if you were given this function and you were asked to determine where the function is increasing, where it's decreasing, start to the left. So I move to the right, my function's going down, so it's decreasing, 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 decreasing until it gets to the minimum. Because once I get past the minimum, now the function is increasing. So it's almost like this part of the graph is where the function's decreasing. And this part of the graph is where it's increasing. And the way you express this is always the values of x. What are the values of x where the function is decreasing? So since this goes on forever, as an interval, where's the function decreasing from negative infinity to 0? So if we're asking where is the function, decreasing, you'd say x from negative infinity to 0. So negative infinity to 0, x equals that, represents this part of the graph. And then where is the function or the graph increasing? Where is it going up? Starts at 0. And it goes on to infinity. So this describes where the function is increasing or decreasing. And the answer is an interval. And it comes from looking at the graph. Now let me explain one other concept that has pretty much the identical meaning, but the words are different. And you need to understand that because this becomes an important part of calculus. If you're asked about the function increasing, another way to say that is the exact same meaning, but just different words. If you're asked where is the function increasing, you could also say where do you have a positive slope? Now in a minute, I will give you a quick reminder about slopes. I think we maybe talked about it in an earlier video, but f of x increasing, positive slope, same exact meaning. And therefore, f of x decreasing is the same thing as a negative slope. Now, if you recall, quick slope is used a lot in math, and you can do lots of calculations of slope. We're not going to do that now. We're not even going to take the time to review that now. Maybe do that later in the class. Let me say for now, I think the key, you think about looking at a graph and you ask about the slope for what we want to know. Think of the slope as the steepness of the graph. So if you start here, as you move to the right, you notice the graph is going up. It's almost like you're going up a hill, and that's considered a positive slope. It's like if you're going up the hill, if the function is increasing as I move to the right, we call that a positive slope. So it really means the same thing as where is the function increasing? You start here, as you move to the right, the function's increasing, which also means you have a positive slope. You get to the maximum, then what happens after you go through the maximum? The function begins to decrease. And if you're going like down the hill, as you're moving to the right, if you're going down, then that region is considered to have a negative slope. So that's why the actual meaning of a positive slope and a negative slope is the same as an increasing function or a decreasing function. So in terms of the meanings of the words, they're sort of interchangeable. And sometimes you'll be asked either one. Some questions they'll say, where is the function increasing? Sometimes they'll say, where is the slope positive? Now, one interesting thing to note, even though we won't really deal with it, excuse me, in this test preparation, but what do you think happens if you have a positive slope, because we're going uphill, and then you get to the max, and then as soon as you go through the max, all of a sudden, you're starting to very gradually go downhill, which means that part of the graph is a negative slope. Now, when you talk about the slope is actually a number. So over here, the slope here could be 2, here it could be 3, here it could be a half. It's an actual number. What do you think the slope has to be at the maximum? So if the slope's positive, 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 although it started to just barely go up at all, once it gets to here, how much is this graph increasing or decreasing? Not at all. It's perfectly level. And that's why we're going to talk a lot about in this class. At a maximum or minimum, that's where your slope actually equals 0. Because the slope, it's either positive slope, it's going up, or a negative slope, it's going down. If it's perfectly level, that's when the slope is 0. All right, well, that'll come later on. So let's just do some more examples. Now, hopefully it's not too hard to figure out increasing, decreasing functions. And so here's one. And I'll just take turns asking for either increasing or decreasing function or positive or negative slope. This one, how about I say, please give the intervals where the slope is positive and the slope is negative. So basically, the intervals where the slope is positive and negative. So here's the horizontal axis. Here's the vertical axis. Well, we go to the left edge of the graph as far as we can. We start here. As we go to the right, looks like the function's decreasing. If we think of this like a hill, we're going down the hill. This is considered a negative slope, and you know what? It never does change. So this whole function has a negative slope. So what's the value of x? X, where the slope is negative. Basically the whole graph. It's a linear function. It starts out negative and stays negative the whole time. How about this one? I've seen this kind of thing before. For this one, let's answer the question, where's the function increasing and where's the function decreasing? And by where, I'm talking about given interval for x, where the function is increasing or the function is decreasing. Look at increasing first. So you start left side of the graph. As you move to the right, what's going on here? Well, definitely the function is going up. So the function's increasing until you get to here. What is this? That's a maximum. So let me just write down as I go. So from here to here, the function was increasing. And of course, this goes on forever and ever. So x negative infinity and -1, that's this part right there. So what happens as we keep going now, as we keep moving to the right, all of a sudden the function is decreasing, and it's decreasing all the way till you get down here. So this is the decreasing. You got looks like a minimum down here. So it looks like, where is it decreasing? It starts decreasing up here and finishes down here. So what is that? That's x -1 to 2. All right. So -1 to 2. So where does the function decreasing? It starts right here. When x is -1, it's decreasing, keeps decreasing up until x equals 2. And then it stops decreasing right here. So that's sort of the middle part. So increasing, decreasing, and then the final right-hand side of the graph, you're here. Definitely increasing. So what I do, I go up here to my increasing. Now, sometimes people want to put a union, which is fine. Sometimes you can just list them. So you put a comma, and then now you write down this interval. So this interval starts at 2 and goes to infinity. All right. So I hope that's clear, the idea about functions increasing or decreasing. All right, a few more. How about this one? This time let's look for, we'll switch back to positive and negative slope. So they could say, where is the slope positive? Where is the slope negative? Or they might say, find the values of x where the slope is positive and find the values of x where the slope is negative. And they offer to give you some, oh, yeah, that's it. Okay, hopefully now. Get the hang of this, maybe not too hard. So start out here. Let's just scope out the graph and then we'll write the answer. Start out here, we're going down. So decreasing, negative slope here till we get to this minimum. So this is a negative slope. I'll just put the negative there until right here. Sometimes I even do this. I sort of break the graph up into the sections. So here's a negative slope. Here, positive slope until you get to here. So from when x is -1 to 0, the function has a positive slope. Here, the slope is going negative again until you get down to this minimum. And then the last section, starting here and moving up again, is a positive. So where is the slope positive? Well, from here to here, x equals -1 to x equals 0. So as an interval, -1 to 0. Now there's also an increasing region here. Starts at 1, goes to infinity. So there are the two, there are the two intervals where the slope is positive. Where is the slope negative? Starting here at -infinity all the way down to 1. And then from 0, to -1, sorry. And then from 0 to 1. I ain't making mistakes. Trying to be careful and pay attention. So just to review, positive negative slope, we could have asked for function increasing and function decreasing, same answer. Let's think about that. Function increasing here to here, -1 to 0. And increasing 1 to infinity. Where's the slope? Where's the function decreasing? -infinity to 1. And then decreasing 0 to 1. All right, a couple more. Some of these are getting a little more convoluted. So this is one where the function or the graph actually has 3 parts to it with a couple of vertical asymptotes and actually a horizontal asymptote also, but it's not here on the graph. You can't see it because it's top of that x-axis. So for this one, let's do positive and negative slope. Let's just go through the graph, figure out what we have, and then we can make the list. Start here at -infinity. What are we doing here? It's very gradual, but there is a slight increase. Or we could say a positive slope. So it's positive slope, positive slope, positive slope. And we can assume this goes on forever. So as it turns out, this first part of our function, the whole thing has a positive slope, or we could say the function is increasing. So positive slope for this whole thing. Then we jump down here. So when we start here, we're really starting at x equals -1. And now we're going to go up. And then we have to stop at 1. So increasing up to this maximum. So once again, positive slope. However, as soon as we go through this maximum, negative slope, the function is decreasing. And the last piece, we jump up to here. So we keep moving to the right. Function is definitely decreasing or a negative slope. So when they ask for interval for positive slope, you say x equals, here's the positive slope, -infinity to -1. Here I decided to put a union sign this time. Any more positive? Oh, we got a positive slope here. It's -1 to 0. So there are the two intervals where the slope is positive. Where's the slope negative? Starts here at 0 and goes to 1. Where else is it negative? From 1 to infinity. All right, hope it's not too confusing. I think maybe 2 or 3 more quick ones. Actually, 2 more. We'll try and. This one will do increasing function, decreasing function. So we got 1 vertical asymptote, 1 horizontal asymptote. Once again, to go to the left edge of the graph, let's move to the right. Pretty flat, but you can tell that it's just slightly decreasing or going down. So decreasing, decreasing, till you get to this asymptote at 2. So this whole part of it's decreasing. Jump up here, and now you keep moving to the right, and it's decreasing, decreasing, and this whole thing is decreasing. Interesting function. There's no place where the actual function is increasing. It's all decreasing. Now be careful. Some people might want to give the answer as the answer is negative infinity to infinity. Well, that's not really correct, because this is saying every value of x between -8 and 8, or negative infinity and infinity, I'm sorry, every value of x, the function is decreasing. But that's actually not true, because you know what? When x is 2, it's actually undefined. So what do you do there? We have 2 choices. You can really break this up into 2 parts. So it's 2 intervals. Negative infinity to 2, union it with 2 to infinity, right? Or sometimes, in this case, all real except x equals 2. Either way is fine. And the last one, we'll go back to a positive and negative slope. Seen this before. Starting here, we're going up, positive, functions increasing, positive slope, positive slope, positive slope, hit our maximum. I'm going to assume it's right here at 0. So positive slope, once you go over the maximum, negative slope. Once you jump up here, as you pick it up, what's this doing? It's going negative slope. Then you got like a minimum here. You go back to positive slope. So positive slope goes on forever. Negative infinity to 0. And positive, it looks like it starts at 2 and it goes to infinity. Negative slope. X starts at 0 and goes to 1. And then from 1 to 2. All right, so that's pretty clear. Don't think it was horribly difficult. So now when you look at these graphs, you can pretty much be able to answer all the questions. Now there's one other video left. One other thing that we like to look at on the graphs. It's called concavity. And that turnabout gives you your points of inflection. Once again, I don't think you'll find it too hard, but we will start that again on the next video.